Right, so maybe it's like, let's say, you take it 80 miles from 1 hour, you go from traveling the time to a function.
But then he had it drafted as like a criminal defense law firm stuff. It's like, you have like, look how much of a tool I am. It's like you're an attorney and you have a
So, wait me for 5 minutes and I'll be back. Okay, so, well, this is. This is so obvious.
Yeah, it's like, it's pretty. You see the.
Yeah. Like, right.
Or like, like off the back of it. Like. It's like very low. It's supposed to be a truck. No, I mean, I don't know anything about that. Have fun. And then some of the videos.
Yeah, readiness and.
I've seen a few of them. You gotta pick up the phone. It's, I guess, about the size of the thing. And there's like storage that's large enough for survival cases. Probably, so that's how it's like. Did you know that? Oh, my God, it was lower than us.
Okay, so we are keep going about the system design. So we last time we just like based on the study case, and then we draw the class diagram. Actually, there's like more details. So just like kind of like review, like we go through again about like possible different types. So when we when you study database, we say okay, for table we have a class, and then we have the name and attributes. So if it is like with some method, then we will add some functions. And we always give the have a verb to describe the relationship of all those tables. And also we will give the range to showing their relationship. That's what we're going to do, have different type notation. And when we look at the documents, we have multiple version, like people they join, like they have using the late circle, and also they have like this one is like one and only one like this. But for representing, so this one I will recommend to use, like if to showing one and only one relationship, just stay on this one. Like maximum one, minimum is one. So it's a one to many relationship, and many will be I will using the M to represent it. So it's instead of extra or like the star. And then the minimum is one. That means at least we have a record. So just remember to everyone just like follow this one. And we have more example right here you can refer to. And sometimes we have for the M2M relationship, for the M2M, we will create one more table. For ER diagram, we don't have to really telling the M2M relationship, but when we design the class diagram, we need to tell, okay, what actual class we have to create. So we will create one more. If you learn database, have you know like how can we change the, I think it's called the third normal form, right? You heard the what's the first normal form, second normal form, and third normal form? Okay, so kind of like when we're doing this, when we have a many-to-many relationship, so we try to create one more table to keep it. Okay, so that's how we show the another table right here. So we break down. So for some diagram that's doing in this way, I recommend just doing like from, let's say, course session, directly point to the course enrollment, enrollment like point to the student in this way. So just don't follow the graph like this. Okay, so here's all the examples that we're creating, and suppose that we just have more like in practical. And one more thing is we have called a superclass and subclass. So we were inheriting. Okay, so if you have an idea right here, let's say we have called a motor vehicle. So motor vehicle is just like a kind of like general information. And under motor vehicle, we have like trucks, car, and tractor. Okay, so those track and then under like let's say car, we have different type of car. So we have like all this like we have inheritance supercars. We can also create in this way. So we say like sales. So if you look at this table, like when we try to inheritance, okay. So you see for sales, we have the dates like priority code, like SNH tax, like total amount. All this information, if you see a little triangle right here, so it shows the inheritance. So in store sales, you only see the store ID, register ID, and the class ID. Then how about other information? Actually, because it's inherited. So all of this we share the same not say share, but they will also have all these attributes. Okay, it's like kind of like implement, just like you say, okay, we already have this attribute, but for all this under is, then they have their own attributes, will be like this. Okay, so just be clear about this part. Okay. And so if you already know all this information, then we can go back to our discussion like this. Overall, you can refer, because for the system design, we mainly about always like first step, try to get the user requirement, like getting what do they need, like talking to all the like internal, external stakeholder of this. So, and then we will, based on this, then we will have the use case, define use case and draw the use case diagram. So this is a second, and then after we have a use case diagram, we need to draw the class diagram. Also one more is called the ER diagram. So if you know the ER diagram, we will just like have an entirety and then have a word and that's it. So that's like I make the video and then talk about like I just like stop by this part. And let's like go back to our Spotify case study that I posted on the week 4. So I just stopped by here because like we need to know more like technical like really design system. So once you know more how actually in reality like how the actual project creates that, or like how this system, the whole structure of the system, then you will have a like better picture, like what kind of question you need to ask, or like what kind of function you're required to build these things. And just like kind of review, let's say for the Spotify, look at the picture. We have like, we talk about, we have a user play the music, and then we have some artists, we upload the music, right? So here's the requirements. Okay. So we have some like use case, then think about what are the use case. So we do talk about it. And for the industry, sometimes we need to calculate, we should able to tell, okay, because all this information we need to think about, okay, so let's say we have a playlist about the song. So we need to calculate what's the storage, and then what's the hardware, like what's the metadata we need to save it, and then where should we put the data center. So we need to like calculate all these things. And we have one called load balancer. So load balancer is when we have multiple server. If we draw in the system design, it's kind of like in the kind of like later stage, but we're thinking like kind of like in the hardware, maybe we have multiple location, multiple server. Then if some of you like taking my class like showing the Nginx, if you know the Nginx, we have one called upstream, and then we can declare multiple server, and then we can declare like different connection. For those connections like round robin, let's connect, like all this. So by this one, we can switch the server. Okay. So if you look at the load balancer, so it's how it actually works. When we have mobile apps, we'll connect to the load balancer. So actually, this one also same will be handled by the Nginx, even though we draw like make it as a I have another picture. So we can use the Nginx to handle the load balancer. We can decay it, and then we can connect to other web server. So if you remember for the web programming you're working on, like I just like quickly go through the one that maybe we have an API server or like the web server putting all the like web page. So all this will be behind in this layer. Okay. Okay. And we need to know, okay, so when we implement the hardware, we need to add the like the API server. Sometimes you hear terms like we have a web server. So web server mainly is like deliver the HTML code and then maybe some static files. But API server we mainly connect to the database, like handle the request, sending the data. Okay. So just like for the instance, they want to play a song, so the request we send to the web server. So the server determine, okay, so which one is located. So let's say I have a load balancer determined. Then how can I retrieve it? Okay. And for the data storage, so we will split into two different services, like let's say the block storage for song. So where we store it. So if you remember the class diagram, so after we design, that's how we actually implement. So we have the one is like for design design for store the song, the actual file. Also, we have the SQL database. So we have let's store the metadata. That means all the song information. Okay, that's like how we work. If like how actually here's like complete picture. So we go through the load balancer, and then the web server. We have multiple servers, and then all these server maybe let's say we have the SQL. If we using the regular RDMS relational database, then save it. And also we have saved the song. So another database, we can retrieve it. And we also need to mention it like for design. Okay, so let's say for the storage actual song, and then here like binary large object. So it's like Bob. And then also this server is designed to a large amount of unstructured data. Okay, we say like, and then for the metadata, that means all the attributes. So will be stored in the SQL database, and username, all the contents right here. So sometimes we just say why we're using the SQL database, just we use the structure. But of course nowadays it's pretty common we using the NoSQL. But still okay, just like depends on what you work. Mainly if you only like just like you do not really rely on the structural content, but just like need to save lots of just like any pieces of data, then maybe you can choose NoSQL. Just give a reason. Okay. And we need to create all the user tables, song tables, artist table, like, and then list all the relationship. So right here, so if you can see some example for the SQL, okay, so we'll create the tables right here, ID, create the link. And if we need to join the system design, when we do the work on the project, so like if you're forming a group to work on it, so step one, try to ask the user requirements, right? And because maybe you're not really asking, or like you just like try to get like let's say make some assumption. Okay, for you just pick up topic or like develop certain kind of app, then try to get a user, and then you design all the diagram. Then you also need to showing, okay, how can you create the database in this way? Showing the what's the primary key pointing to it, listing structure. And then here's a overall picture. So when we're adding more the database, like right here, create the tables. Is move on, the structure will be like this. So the graph, of course, you don't have to like drawing really fancy like this one. Just using a scope, the square or rectangle, the box, put the name to showing the structure. Okay. And when you need to design, let's say for Spotify, we always they have a large scale of data. And try to ensure like we need to always a high availability or like also uptimes. How to handle like privacy data protection. So all these will be doing this. If we are like for implementation, we need to think about if the user increase, then how can we handle? Of course, like for your project, we just like need to put some assumptions. Say, okay, let's say we just need to handle for this much or this much data, or like how many user will access it. Just make some assumption. It's okay. Okay, but in reality, we do have to because the usage of data always like goes up exponentially, so always need to be careful. Okay, so just like one more, if I keep going, and one more terms we will hear a lot is called the CDN, called the Content Delivery Network. So we always like helping to doing caching, CalFan. That one is like help us to checking based on the location. Because depends on the maybe country actual location, then we will know, okay, so which server will know like which one can access faster. Then we can deliver the content to the user. That's what we are actually doing. We are not really asking you have to implement it, but you need to have an idea like, okay, so if I need to design a system, we always need to consider, okay, as a huge or large scale system, remember we highly rely on the CDN because CDN help us the adding the caching. Actually CDN like caching to access it also for database. We also need to remember to talk about the caching. Okay. But for this one is more like in for the industrial level. So you need to know how to mention this, but you don't have it. And then let's say for this one CDN, we use the LRU. Sometimes it's the term called the least recently used. So we have different mechanism. So like round robin is like just like taking terms. So first I use 1, the next one will be 2, 3, 4. If I only have like 4 web server, then I just like taking term round robin is like okay 1, 2, 3, 4 and go back to 1, 2, 3, 4 taking terms. But like let's use is like okay least recently let's say using 1, 1, 1, 2 and then 3, 3, 3, 4, 4, 4, 4, let's say like this. Then 2 is the let's use that I will assign 2 to it. So we have different mechanism to do it. But for system design, you just need more. This one is more like advanced. To think that just need to know. Okay. And you see like for the CDN, it helps us to quickly access the data. Then we don't have to we have the caching. So we increase the speed. So the overall picture, this one after we add the CDN. So it's a normal way. If I first time retrieve the data, I go to load balancing web server. But if I already retrieve like get the data before, then I can just like go through the caching, get the data directly. Then I don't have to. Okay. And when we have more or new data, then we need to like explain it. So we need to let's say get more reads than write, or like as like more user to listen to the song. But like relatively small amount of like artist upload song that we can use the called the leader follow technique. And this one called the leader database. So I have only one to like doing read write and then maybe a multiple follow or slave database. So we'll be read only. So here's the pictures. So we can like create more. So you can see here's like more details. So we have a leader and then some follower. That's why when we read the database, so we will just like okay for this one I handle is like read write and then for we just like handle the read only. So just like get the song. So we can reduce the workload of the master, then they can share the resources like better. Okay. So just like for others, maybe nowadays we can add more on the like using AI to like better for recommendation and then other possible. So here's like for the API also using the Spotify to build it. Okay. And then we will keep on like talk about because like we try to more practice on how to draw the for the class diagram. So I will showing you how to taking the Spotify again. Okay. Just like going back to here. Function. Go back, where is it? Let's say we can stay here. Okay. Anybody still remember like we talk about like we have some use case, right? some use case, like based on the use case, we try to draw the class diagram. So right now I have a whole pictures. So we try to like, okay, so for the whole system, here's the final picture, like everything right here. Okay, of course, I'm not required to like, we can mention it like for improvement, like sometime in the project, you say, okay, we can like for efficiency, we can use the CDN for like caching or like for design the database. But just like for study, like in this class, you don't really have to really decide how to design the leader or like the follower. But we are just need to put the class diagram. Okay. So we just to practice more. So we didn't I didn't ask you to draw the ER diagram. So we start with the ER diagram first, just to help you to recall the memory. So we just like go back with the beginning, some picture like this. Okay. So anybody be a volunteer, like start with the ER diagram. Yeah, do you remember how to draw the ER diagram? Just like using the user and we have the artist play, then how can we draw the user diagram? And also we have some songs.
Rusty on doing that.
Yeah. Pardon?
I'm a little rusty on my ER diagrams.
Yes, yeah. So can you show? Yeah, because like start with the, we can start with the ER diagram first. Okay. Well, in the previous lab we did use the use case class diagram. I didn't talk about the ER diagram, so this time start with the ER diagram. Okay, so I have one with the functions.
You give an example of the ER diagram that I can talk about that.
Okay, okay, let me show you the ER. Just as what you remember, how can you draw it? Like, then we can, I will based on what you draw, then I will tell how we can draw the ER diagram.
Yeah, now I get it.
Okay, so
I think it's
okay, so this one is not the ER diagram. Okay, so this one is not the ER diagram. So anybody can help you. What's the ER diagram?
Yeah.
Yeah.
I get that.
Okay. So user. Okay, so right now, if using the Spotify, so if you look at this one, we have songs, we have the user, and we have the artist to upload the file. Like I give you the background like this, then how can you draw the ER diagram? Okay. Because we have so many diagrams, I think like maybe some of you are like confused. Okay, if I ask what ER diagram, then you give me so many.
They're only pretty similar.
Yes, slightly different.
users,
Songs.
Okay. Let me, when you look at it, let me show you one more. About the before.
last semester.
Okay, where's he?
We do for private users. So, right? So,
Anybody sure? For ER diagram, do we need so many things?
Do we need what?
Do we need the primary key or the things?
Uh,
Anybody can help or like ER diagram? Okay.
Yeah, we should improve.
yeah, primary key for user should be user ID.
When you're drawing it there to get the want some example.
Okay.
So there's no.
Artist, yeah, like switch artist ID.
You wanted to put a star next to each of those, like, then you think that you can.
Yeah, because I need to make sure one thing. Okay, yeah, you can keep on drawing. I'll let you finish. All right. If you need help as student, like,
The relationships, users first have songs. Yeah, one word's got any songs. Go elimination, but
To do that, it would be. And one.
okay. The user could have any songs, so
The user doesn't have to,
songs.
user's free. Play a song, but the user doesn't play a song.
Yeah.
Associate with them. Play that song.
Yeah, so you can make a playlist object.
Yeah.
That's good. I think it'll be many, because many playlists have users.
You need secondary keys. Foreign keys.
Foreign keys.
You definitely need, artist ID.
Yeah.
Song.
when you're showing somebody helping. So I want to know, when you learn the diagram, have you ever seen the diagram look like this one? Like this one,
No.
or just like the class like this one, like,
Like that.
or like this one? Okay, got you.
I was right. Well, the good one makes is like, well, four can be like for many, and one is a single line.
One for.
Yeah, but it's kind of with songs. Could be in several playlists. Say in like user, and their users. Yeah.
That one plays. Let's play this.
So like roughly is okay, just like it. And what else? The name is missing something or somebody can tell, modify or like different. Is the correct year diagram?
I think so, but I think I.
Yeah, so we're main reports.
Okay, you remember. Okay,
That's what I remember now too.
okay. So
Yeah, we're 4 minutes.
okay. So what's the year diagram? So the full entire relationship diagram. So then what we have shown, thank you so much. Okay, so we have for the use case, web and none. So we just like enter and then some use case boundary. And then class diagrams really talk about class. So for class, we have the name and the attributes, right? If this is we do have a method, we put the functions over it. If you learn it's really if you didn't see the format of this one. Therefore, the year diagram, of course, you can show in this one, but if you're showing the table like this one, it's like much more is closer to a class diagram because it always show the all those like information. Okay, so sometimes it's like kind of confusing. Okay, when we talk about year diagram, actually it's more likely in this way. So, okay, so we don't have to make it really so complicated. When I ask you to draw a year diagram, like maybe in the system design, maybe they flash you. Okay, just make it really simple. If for entirety. So let's say we have a user, just give me a rectangle. User, okay. So I say, let's say I just need to provide 3 attributes. Okay, maybe I need to have a user ID. I always come user ID. If it's a primary key, just give me it's a primary key. So do we need to care about what's the foreign key? We don't have to think about that in this moment. Okay. And then this one is the entity. Okay. So there's an object set. Okay. So we need to show the relationship between others. How can we connect the relationship? If you remember the verb we're using, so we always put the relationship like this, and then another like this. Like this. Okay. So this is how it looks like. So we don't have to make it really so complicated. So of course, if you ask me, can you keep doing drawing this way? Okay, if you want to learn, because sometimes I know the style or how they draw it, come and make because it's easier. Like or like when I use the database. When I try to create the database, maybe you can just like generate the diagram like this. So they just use it. Of course, can you see the entire relationship? Yes, you can. But when we try to design the table, like really going back to like rolling back to the first step. When we thinking about what the possible entirety is, like what the words, and we're using this one to join. So it's really give us like kind of like brainstorm. So we know, okay, so we will know, okay, we have user, what kind of possible attributes. Okay. And right here, let me show you. If like this one is for assignment for something drawing, if I ask you to do like draw a year diagram, just use this one, it's fine. Okay. If you say, can I do it in this way, user, and then like attribute like this, and then frame. Yes, of course, you can do this one, but I think you don't have to make something. Just follow this way. Okay. Okay, this one is a verb. So it's like let's say I will play a song. Yes, okay. It's a more like verb. So like yeah. So if you remember, we draw the. If you remember, we have UML this one. So I ask you to play like this one, the relationship. Okay. So let's say for the user, and sometimes we say page view, just like using song and thing. Okay. And then some user. Okay. Nice. Like this user and songs we play. So always remember, how can we put the relationship? Also the one to many, where's the many? If two users. User can play many songs, okay. And then how about song? Many.
It would go many.
Okay, yes, it's a many to many. So just put a relationship right here. Well, right here, you know on different textbook, like when you're learning, you have multiple. So when you learn, are you using this way or this way?
I use the floor, even the forks and line.
The forks and then this one?
Yeah.
Okay, so you're using this one. Okay, I don't have to really force you to change it, but you don't have to put it like choose either one of it. Okay. Good. For my style, I just using the numbers like many. So I'm not using this one. So if using, although if you putting like this, then at least it's everything is correct. So. Okay. How about this one? How do you think? So do you think this one is correct? I think maybe. Yeah. You're same, but can I bring this one?
Or no, we were saying, for the playlist.
Because we have the name, if we refer to the, yeah. Okay, for the different diagrams, sometimes we call it, cardinality or like the multiplicity. So it's like talking about the relationship, also like the minimum and maximum. Okay, so if for the two relationship, but you put it in the middle, then I will ask, okay, if I need to talk about the cardinality, then at least like I have at least one right here and one right here, but not just putting one in the middle. Okay. Okay. So either is that okay, if you want to show the relationship, at least you can like let's say this one many to many, then you can many to many. Okay.
Yeah.
Just like this one. Okay. So if I need to show the range, like continuity, and then I can do it right here. So for the playlist, okay, so it's like back to the playlist. So when are there many to many relation? If I asking for the ER diagram, for the many to many relationship, you don't have to create extra table. You don't have to put it down. But if I ask you to draw the class diagram, because the actual class, right? Then you need to change the many to many to, I think, one more thing. Okay, for this one, I will invite the number here. And one more thing is that important. Okay. Let's say for the playlist. So it's the many to many, right? So how about what's the minimum? One or okay?
You could have.
Can the playlist one? Okay, we're going to say one. Okay, so can be 0 or many.
Would have had been created this.
Okay, then like 0, 1, or n. One. Yeah. Okay. One. Explanation. Okay. Okay. So why one? Okay. Has to be somebody created, but okay. Then can the place owned by multiple users? Is it possible?
Well, I don't think so. It can be shared, but it's on.
Yeah, so if you look at the reality, actually when you create a playlist, so just like you when you create your own playlist, can somebody create by like your playlist so like okay somebody create this one too? Or somebody open this one?
Yeah. I guess it would show like, who created it initially.
Okay, but this one is like kind of like if we using create.
Yeah.
Okay, and just one, okay, yeah. So sometimes we need to work to like show you the relationship. But because when we like we share or like cooperate together, then maybe if we have another relationship. Okay, so but at least like we should have minimum damage like this play this at least be created by one user. Okay, does it make sense, right? Yeah. Okay, it's important that the playlist exists, but nobody create, so it's impossible. So I say that's why we say what's the minimum. Okay, so look at this one. How about n? That was the minimum of it. Any other or any answer?
If you're creating a playlist, then there's one to do that.
So one, say one, 0. Okay, and how about others? Who are thinking 0? Will you say 0? Okay.
I mean, I already said my piece.
Yeah. Then who are thinking is what? 1. How about others?
You see.
Which type? Okay, either 1 or 0. Okay, just choose. I want to see. 0 or 1. How about others right here? This group. How do you think? Which is it 0 or 1? Yeah, 1. Okay, 1. Okay. 1. Oh, you don't know what to do. 1. Okay. Okay. So when we talk about minimum, just think. Actually, you're right. It's 0. Okay. How do we? I say 0. Correct answer is 0. Then 1.
Because you could think of the number of playlists that could be created, you have a new user, and they have to create a playlist.
Yes. So that means like in the catalog by default, actually you have no playlist at all, right? So it's 0. Okay. So here's how when we thinking like when we join, if I look at the relation like this, I ask you to look at the relation like capability or like participants. If you need to put then I'll look at it if it makes sense or not. Okay, so for this one, then will be like 0, and if you put it 1, then you will know something like I would deduct like some of the points. Okay, and based on this one, just like follow. Okay, so keep going. If I want to change something, because in the PowerPoint I talk about inheritance. Then I would like to change the structure. So why not we put the artist right here, right? And I want to just like make a follow up. Let's say right here, you remember we have the user, premium user, and system admin. If I want to change the structure a little bit, I just so why not just stay on the inheritance. So if I want to let you to draw the inheritance diagram, like just like using this one, generalization, if this one, user and premium user, how can we draw that? And also the system user. If I are asking you, so okay, please draw the one like this, then how can we draw it?
The user has the top one.
You want to try? Okay. Or practice this. If you want, you can have enough space, then you can do it. And because all this diagram, it looks easy, but when you logically
Right.
mix up, then you think it's right.
So, when I was doing it, I felt like I had a relationship between pride, like a bunch of other entities, like at least 6. Is there a way when you're creating class diagrams to break things up when you have like so many things overlapping? Like, where you just kind of have to like make it better. If that makes sense.
But you need to show me these sites.
Yeah.
Because, like, if it's too general, it's really hard to answer. But I will wait after this one.
Yeah.
We can discuss this one. So I would like to ask that. Okay, so if we talk about inheritance generalization, so how would you?
I would just have a parent user class and that would all have everything that everyone has, so like login information, regular settings.
Oh.
and whatnot.
Okay, so I would say like attributes. Oh, can you list like 3 attributes? Like
Three
like for kernel and for user.
So they would, login. um, Does that sound?
What's login?
Login would be a username and password.
Okay, so if we say username password, then that one is really that attributes. So
Split them up.
so if you have the name, let's say you should put the username and then password. Okay. Therefore login then more likely is a function. So we just I'll say 3 is enough. So like okay, yeah. So just put 3. Okay. So we have the username, name, and then how about premium? So
How much they
so
pay.
okay, for free. But if you're gonna make 3, it's okay, because sometimes like for user we have shared attributes. So maybe it's more, but sometimes for the inheritance, the superclass we have more, but for them maybe 1 or 2. So just next.
Right.
Okay, so okay, we need
So premium users have to pay. We have premium.
Okay,
So they figure the monthly,
okay.
and then
Maybe possible when they. Normally, if we, for subscription, what kind of information will be included?
yeah, subscribe date.
It's important because they always check.
Yeah.
It's going to expire, I have to send a, it's expired, should, we want to renew it, okay, so.
What the type of subscription,
Yeah.
whether it's premium or free, type of subscription.
You can put that for users over it. Because if you're gonna have like type, then like this, like.
We didn't really need to type because we separated all of our different types into different
Yeah.
classes.
Yeah, because why not just like make the question like for just like the generalization, so, yeah, just like. Okay.
We don't really need that. Yeah, I'm gonna move to the system admin.
Okay.
And so they might be like a root ID or something, to allow them to use.
Yeah, this one is the pretty good, part to discuss. So. You're right here, you were putting the system admin under the user. So. Okay, it's not more a general name, username, and. Yeah. There's no more, that's you, but I just want to ask a question. So, how many of you thinking it's a good idea putting the system admin under user? Or should I take it out as a separate? So I don't have to put it. Just like user and just premium and regular, and then system admin I should take it. So. How do you think? This one is.
If the system admin needs, the username and password, then I would say leave them on. Because they need it anyways. And then the system admin would just have more.
Right,
specific functionality.
yes. Yeah. So when we decide, okay, so we always say for generalization, it's a user can be any user, right? Even admin can be also the user. So I just need to keep the name, username, password. Are they all require this information? Later? Yes, we do. So then we can put under. There's no action, but because like we have just like apply because we study what's the generalization, we have to draw something, and we try to put it inside. Okay, but for real life, maybe we can take it out. Okay, yeah. So really depends on where we design the system. No, actually. So, okay, we can put under it, then how can we decide? So let's say right now we are putting it like under the system admin is under the user. Okay, so what else?
They need. Well, what kind of actions can the system admin do?
Instead of thinking like what kind of data, like right here, when we're talking about the ER diagram, showing this one, we're thinking what kind of data, metadata or attributes for the. So if we have let's say we create for the admin. So here will be the data, like if I inherited, so let's say I have a name, and then the username, and then the password, and what else?
Right.
Any content.
Yeah,
Yeah,
yeah, anybody have a
Well,
idea
yeah.
of what the admin would do?
What do we need for the admin? Well, yeah,
I'm not sure,
yeah, just you give yourself and then open this.
yeah, anybody? What is it?
So if right now we are like for generalization, then we need to
put the system admin under the user.
then what are the attributes do we need?
I mean, admins can create playlists.
That one is more like a role or a structure, so but not the attribute. So we're talking about attributes.
Yeah, no, like if we don't really doing this, you will make some confusion.
Yeah.
Okay, so what the attributes do we need?
Uh,
The thing is the data.
I don't think that would, I don't know what you would do for that. I think add, remove content.
That's still a function, it's a. Yeah, like it's they were, I guess they would be an employee, so.
Yeah.
Hire them.
Yes, okay, okay, are we good? Okay, yes, okay, good.
What powers they have? Current supervisor.
Permissions? Like some supervisor or manager, right? So it's for the unary, so if you remember the database, the relationship. So we set a role. Yeah, the role, like maybe role or like who are the manager, department, who they are employee.
Perfect.
Okay, so that means that if this one like under user, and with others like let's say we have maybe the hire day, like employment day, and so we have their role, but they have a position, right? If they are admin, maybe different type of admin, and also we have the department they belong to. Yes, true. So that will inherit. So when we join generalization, they will be like this. Okay. And if like more like we just like follow the structure right here, just like get it out. And then just like this.
Yeah.
And then. So just follow this one. Okay. So if we ask you, I ask you to draw the ER diagram, you have to just draw the one like this, and then maybe for each of them, you have the actions we can do. Okay, so
This is the ER diagram. We are going to, and then one. Okay, so based on,
and then one more question. Okay, so to follow up. So as ending the last one, okay. Right now we are mixing everything right now. So yeah, diagram, I just need to showing the entirety, also the relationship. So it's okay, everything relationship, I just need maybe 3 attributes. You are not required to put so many things for this. Okay. So if I right now from this one, I want to change it to this one CR, then I want to say I want to change to cast diagram. Only these 2. Then how can I modify this? Do you think it already fulfill the requirement for cast diagram? Okay, anybody? Okay. So like just based on these 2, playlist, user, and then go ahead. Okay, say, go the class diagram. Just please. Yeah, because this one's many to many. So I want to see how much you understand.
Oh, okay.
Class. Class diagram. If you need to create a new one, you can use this.
Yeah.
What's that?
Okay, so right now we have, actually this one more like is yeah, that. Then I ask you, okay, I only just need to look at these two tables.
Yeah.
And then I want to like come back entirety and then change to class type. So here's the things like for class diagram, so with ability class, we try not to keep the many to many relationship. So if you don't want to keep the many to many relationship, your right now is like many to many, like okay, create is not possible, but play is. I just assume not with just assume because there's no many. Okay, let's say this one is many to many. Then when we draw the class diagram, we need to create. One more. Okay, okay. Just I want to let you know. Because in here diagram, I don't need to care about the many to many relationship like okay. But when we really decide the class diagram, we won't keep that many to many relationship in our class diagram. So we need to create extra table to change to one to many and one to many. Suppose we be like this one. Okay. And just like be careful about this one. Okay. So if I say, okay, yeah, diagram, okay, you can stay on this side. If I ask you like draw a class diagram, remember to change to grade. Okay. If you once you draw something, then it comes out maybe Sean and Haley's. Okay, Sean and Haley's. And let's see, let me see. Do we have enough time? Okay, quickly. If somebody okay. Sean and Haley's, how can I bring it down to like 3 tables? Okay. Okay. First.
So you could have your playlists. And then you have your users.
Okay.
And then this one would be kind of mix of them, so it would be user.
Playlist, okay, playlist.
And so this would be all the ones you had user that had an ID of one, playlist that had an ID of one.
That would say ID.
Yeah.
We put that user ID and playlist ID.
Correct.
Okay. We always put the attributes, but not the attribute. The PID. Have I understood that? It's just like, okay.
And then the user, this one would combine them.
So normally combine, okay, so when you are learning database, is that we can use the. When you use it to form to use it as a community, we are community, but for actual implements, I would always recommend to create one more ID. Okay. So we are very using in practical, like this one is really practical. We always create another ID for the table. So always when we have an ID, even somebody said user playlist ID. Okay. So I would recommend you do this and then UID and yeah. Okay. And then the MK and as well. Okay. And maybe sometimes I ask you like to provide one more attribute, like user and just name or previous name, but it's not. But sometimes like when we create a relationship and then if we have some extra information, then we can just add it right here, like only specific or any. Okay. So that's how it looks like. Okay. So from here to class will be like this. Okay. Just remember those things. Thank you. Okay. So far it's almost the time. So it's like this everything we cover like for the previous slide when we talk about the use case and then about class diagram, and then we need to know more the cardinality and also the inheritance generalization superclass. So it will be right here. So when we combine everything. For showing the relationship, we'll draw this one, but when we actually go to class, we won't see the actual implement. Like this. So we can enter it in the practical. So right here, and it's almost time. So this will be for today's class. Okay. Have you? This one I didn't really cover. That this one is called parts. It's like it's a component of it. Okay. So especially if you are something including maybe hardware like there, it should be included, then you should add it right here. So it knows like computers, maybe like adding. So we should have a monitor. And then we have a storage, and then like input devices. Okay, but itself, we can have input devices. That's like how it's showing the relationship. So it's like for the computer, if we need it, then just put it right here. Okay. So if we don't have processor, can you call as a computer? No, right? So it's really put in right here, right to the one we form it. Okay. So computer is like combining all these like processor, main memory, input devices, storage, maybe the monitor together to form the computer. So if we have any if I can find any others use case, then we can keep on to draw some example of the diagrams. And that's it for reviewing of this one. Thank you.